fell within that. So that was the requirement. But normally commercial and military satellite, this value will be much stringent. So accordingly, we have to use a better sensors. Okay.
Yeah, thank you, sir. Thank you very much.
And this is the different nowadays. Earlier used to have very high gyroscope, large weight, but nowadays a lot of MEMS gyroscope, space grades are being available, so one can use that one. But these are also commercial gyro IMU, which contain a single IMU package, contain triaxial gyro, accelerometer, and magnetometer. Of course, accelerometer was not required, but in some of the cases, if we are going geosynchronous satellite or when we use the moon mission, accelerometer played very important role, particular so that the required delta V is achieved. So that was there, and sun sensor primarily used for requirements, and along with the magnetometer, and the magnetic torquers are used for controlling as an actuators. So these are the different components, and they are all built in. We have designed ourselves. Only this was the standard item available of the cell. Anyway, I will not go through the specification. That again depends upon type of specification, type of devices we use. So we'll not get into this much detail, but it requires that one. So different kind of, now we design particular this ACS with a simple application. We did not put much complexity. So like a launch phase, different modes we have defined. Launch phase, suspended mode, where that is the ideal mode, detumbling mode, which controls the rate of the satellite, and then finally 3-axis mode. And most of these things are autonomous. And in case is required, you can make it manual. By demonstrating this, we understand our students, they will able to design the satellite, complex satellite, because the basic concept remains same. Yeah, this is what the same controller what earlier we have discussed. It also involves a lot of hardware and software. As I mentioned, we require a good controller and different sensor, actuator, drivers, and we have to design such that at least the graceful degradation can be achieved. University type of satellite, we cannot provide the redundancy, whereas the commercial satellite does require redundancies. And in most of our ISRO experience, they require redundancy everywhere. And this is some of the operating system for the software, simple operating system developed by ourselves, and that was used for satellite. Now, apart from the satellite onboard system, we require a lot of ground system as well, and this is called the test system for this thing. So particular meeting before we design, before we put the system in the satellite, we have to carry out the lot of testing, and this particular ground system is equally complex. But since it is a ground system, the reliability requirement is not that high. Components can be used either commercial or maximum mill grade component. Only what take care to be taken is not damage the onboard system. Okay, so these are the different component of the scepter system. Normally, these are designed based on the available of the cell military hardware systems, military grade hardware system. And such that the software is developed such that all the parameters, whatever is required, which can be displayed in a conventional, and it's a very convenient way, so that directly in an engineering unit, normally whatever the data is available in the satellite, we don't transmit into the engineering unit, we transmit as a data, integer data, particular to reduce the bandwidth, and then we convert into engineering unit at the ground and display so that it is transparent to the user. Okay, and this is, as I mentioned, is
Sorry,
assembled.
Doc, I have a question
Please.
regarding, regarding you said most of the components are cots off the shelf. Now,
For
do you mean to say there is no component which is a controlled device or
no,
has
the
any proprietary or patents and all that, so that everything 100% of these components are off the shelf? That's what you mean to say?
yeah, I'll just tell. Uh, I just tell is this component, the two type, which are the test system related ground component, which are of the self. There is no ITAR application for that. Now, for the onboard system, there is nothing like patent, but these components are available in the market. And if it is a very high radiation capability components, means what we call typical more than 100K, they are ITAR controlled. But I saw of late, particular companies like a Texas and all those things, even those components are available of the cell. But that we have to go through, particular for the onboard component. We have to go case by case, which type of components are required. In case certain components are not available because of the ITAR, or ITAR means that US put a restriction, that is a restricted component category. One has to qualify that component. We purchase military grade component and we requalify those component at our cost, so that we get the confidence. Otherwise, we have to have some mitigation technique, particular for the radiation, to take care about failure of these components. Does it qualify? Does it clarify your question?
Absolutely, it does. But one more thing that I have seen
Yeah.
in, let's say, in telcos,
Hmm.
service providers, they also have a lot of telemetry data,
Yes.
which are ground components, but
Yes.
they are still controlled by the government or by certain
Ground
regulations.
component, I don't think anything is required. We can design ourselves. In fact, normally we design ourselves ground component, ground system, which are available. At the most, see, ground components also different category. One is pure commercial, other is the industrial range, then is a military grade thing. In case military grade things are not required, we can go for the industrial grade and requalify at our facilities. And difference is, the normally industrial grade will be right 0 to say 80 degree centigrade operating thing, whereas military grade will be minus some value minus 10 or minus 15 degree to plus 85 degree centigrade. So we can purchase this industrial component, qualify, and which are successfully qualified, those components we can make use for such application. One has to go through case by case. Otherwise, we have to provide enough redundancy to take care about any such failures.
Got it. But s-
But
but
normally, we
but
never
for
face any
telemetry,
problem.
there is nothing special we need, right?
Yes, nothing is special. All design is done by us, and in my opinion, in ISRO experience, we never had any problem in the ground-based systems. Where it can be a little bit ITAR control thing, suppose we require certain facilities like some simulator, and which we are not making, we buy off the shelf thing. Sometime they will have a restriction, but then there are alternate means. If USA is putting restriction, then we have to go some European. Now everything is available in European country as well. So that is where the state, but uh, they are available components.
Yeah, right.
Okay.
Components are available, but let's say, when you procure them, the manufacturer will ask you where you're going to use it and all that.
Yeah, that is utilization certificate we have to give.
Okay.
Utilization, because that is a protocol they follow, manufacturer.
Right.
But
Okay.
but certain components only, say manufacturer will I ask two type of component. One is restricted component, other is non-restricted component. They still ask for non-restricted component utilization certificate. Whereas restricted component, it has to undergo by their Ministry of some foreign affair or something like that. So or defense ministry to accept, not defense ministry, what they call as the Ministry of External, which is equivalent to our India external ministry. So it has to undergo that one. But unless it is a very, very critical component, it is possible to get those components. Component as well as the subsystem. But subsystem, particular for ground application, most of the subsystems are available from European country, which they do not have much restriction. They will ask end application, but they do not have much restriction. Okay.
Okay. Thank you.
No. So this is all assembled view where we have, as already mentioned, they try to before actual design of the component, design of the hardware, we first do a fit check so that later on there will not be any surprise. Now, more important, again, it comes when the satellite is launched, the major activity will be mission operations. And because that is what is going to live for the life of the satellite. Once the design is done, satellite is launched in the space, only the mission and ground system, ground station, that will be active. And that is where we have to design when we want to take the picture, what is the application, all those interfaces we have to design. And here we found particular our students, they got lot of experience and excitement how to command a thing, when to take a picture, when the satellite is running. If it is a near Earth satellite, it will come to our like Sansunkana satellite, like a PiSat, it will come two times in the morning and two times in the evening for a single ground station. That we have to find out. If we are having hiring more ground station, then it can be a more continuous basis. But we have to, each time we have to pay the cost for the ground station. So that depends upon uh, application to application. How many ground station you want to hire, and that will be the cost of the station. Then yeah, one has to design. During that design itself, mission design itself, we have to design windows, launch window. You must have come across uh, recently also lunar 3 mission, Chandrayaan 3 mission, it was launched delayed by few seconds. Now for general public, few second delay doesn't mean anything. For the satellite, its delay means some reason. And later on, I also read in the news, there was some debris in the space. They were coming in the flight path of the satellite. If a debris comes in the flight path, then it will be a problem for the satellite. It may damage the satellite. So one has to design the satellite accordingly. One has to design the mission when I should launch the satellite. And particular for the sun synchronous satellite, when the satellite will come at the particular time in the ground, that also will decide about the launch window. Again, we have to also see which launcher we are using, and there are many launcher, India launchers or PSLV launcher, otherwise other SpaceX launchers, and so many launchers are available. We have to design the compatibility for the different launchers. Similarly, the local, as I mentioned, the local time constant also will design. When the satellite launcher leaves the satellite, we should able to acquire the local time. We should acquire the orbit such that the required local time can be achieved. This is particularly important for the remote sensing application, because we want to take the picture of the local picture only at particular time so that the sun inclination remains same, like the sun lighting will remain same, and that is why, that is how we can take particular for this kind of band. Whatever we use remote sensing, cloud and all those things will not come into picture. Optical range, if you are using cloud, will come into picture. But IR spectrum and all those things, cloud may not play much role. Anyway, these are the typical observation of our satellite, whatever was launched, and this was the for PISAT application. Okay, and this again, it was launched like here. If I find the difference, if it is a near Earth satellite is directly launched into the required orbit. If it is not launched in the required orbit, then you required orbit correction. But in PISAT, we were not having that capability of liquid propulsion. Otherwise, for bigger satellite, we essentially require a liquid propulsion so that we can, at regular interval, we can correct the orbit. Because once we launch the satellite, orbit also keeps on drifting, and which may not meet the ground condition. So that is required. But here, it was a magnetic control simple satellite, and there it will be a launch. It was launched in a required orbit. In case of the geosynchronous orbit, we don't launch directly into the geosynchronous orbit. It is launched into the intermediate orbit or transfer, they call the transfer orbit, which is 200-kilometer height here, and here it is 36,000. And after that, we have a apogee 1. This point will be called as a apogee. Apogee 1, we make the circular 36,000, which require a couple of days of operations. So this is what the total overall schematic design, and this is the ground station data which we are sending through command to satellite and then getting the data at the ground. Now this is what is done. What I was just asked to just give an estimate. Now, unless, as I mentioned, because my whole purpose was explaining you the other satellite, understand the requirements, like depending upon the payload requirement, configuration of the satellite varies, and the cost also will vary. We worked out a typical, this is nothing very hard and fast number. It for university satellite varies from 2 crores to 10 crores. Here, mostly the cost will depends upon the configuration, like which payload we are going to use, what is the actuators we are going to use, what are the sensors we are going to use. But they will not be very ruggedized. For commercial satellite or low Earth orbit, this is, again, this varies from 50 crores to 100 crores, depending upon the site. Here, major percentage goes in, again, the payload and actuators, sensors, and so on. Now, for military satellite also will be of similar order. Sometime they could be cheaper based on that, because military satellite, they launch very large number of satellite. What I understand from the literature, US government, they launch very large number of satellite, but they're very small duration satellite. Of course, this will not be available openly. This is available some of the literature. So if one satellite goes out, you launch another satellite without much redundancy and so on. So that is what is required. Geosynchronous satellite primarily used for communication or any of such kind of, which require 24 hours availability for the ground spot, and that will vary depending upon the satellite configuration. The minimum satellite will be, say, 100 crore. I am talking in rupees. You can convert into dollar or whatever it is, and to 500 crores or more, depending upon this thing. Equal amount of money, whatever we mentioned, the satellite, it goes for launching the satellite and ground station maintenance and so on, because ground station and maintenance is required for the lifetime of the satellite. So that is what required. A better estimate can be, I think, typo mistake. Better estimate can be worked out after the finalization of the requirements and the configuration. Yeah, this is what I have worked out. Now, any specific thing, if you want to discuss, we can discuss. I request my colleague, Dr. Devraj or Dr. Silpi, to add anything if I missed anywhere. Dr. Devraj,
Sir, we have covered almost everything. Let's hear
Dr.
from them.
Silpi.
Yes, sir. I
Dr.
see every topic covered here. So we would like others to raise the question if they have any concern.
Okay, fine. So if you have a question, now what I want to tell, we keep ourselves team, very small team, because keeping a very large team, we have to payment is very, very high. But we have a team working for us based on the requirements. We have all set of retired people, those who are 30 to 40 years of experience on each field, whether it is a control system. Of course, control system myself is having that kind of experience, or the onboard computer, communication system, structure, thermal, or mission related activity, or in general for all those ground tagging activities and all this application, we have a set of people. As and when the requirement comes, we involve them on the case by case basis, but they have a commitment to work with us. That is what I want to just convey. Okay.
Yeah.
Now, any
Thank you.
question, any further clarification if you want, I can.
Sir, I have a small thing. This
Please.
costing includes of infrastructure, or it's only just
No,
components?
no, not
Doesn't
infrastructure. These are all components. A satellite. See, this satellite infrastructure costs quite a lot. If I go to vibration table, that itself will be some tens of crore.
Yeah,
If
that's
I
what
involve a thermovac chamber, I remember in our satellite center, a thermovac chamber, it was costing some 150 crore project when way back somewhere around 85, 90. That cost will be much more. So, infrastructure cost will be much more. So best way is that suppose we don't want to involve too much, we don't want to put too much cost, we have to hire these facilities elsewhere and pay their charges. That is what.
Yeah, I got the question. I got the
That
answer.
is what the thing is required. And nowadays, even ISRO is open through some channel, as our Dr. Venkatam was mentioning, that in
NSL.
that cell invest where we can communicate with them and we can get that facility based on our contract, whatever we make for that. But for a couple of unless we want to have a continuous development of satellite, there is no point in making infrastructure. Okay?
No. Yeah.
Yeah.
Got it.
Thank you.
So if I know more details of the requirements, either we can talk orally or you can write in details. We have to study them. It requires some time. It is, as you understand, each subsystem is a function of the payload requirements. So once you decide what is your payload requirement, then probably we can work out the details. Okay.
Yes.
Anything more, Dr. Venkatam, like to add?
Thank you, sir. And Vasi, or you have any other things to add, or what is our next steps you can suggest, sir? Are you there? You're on mute.
Yeah, I'm still here. Wasim, are you there? Do you have anything to add in? Because I would. Is Wasim there?
Wasim, I
Wasim,
think not there.
he
Just I think he
dropped
got dropped or something.
Okay,
Just now,
I'd
recently.
like to make it very simple and very straight, Dr. Agarwal. So
Yeah.
I'd like to put in a very layman's language. What is the roadmap that you have, and what is the expectations that you're looking at?
Okay. I do not know your end application, but in general, what I would like, if suppose you have to develop the space capabilities, we start with a small satellite with full-fledged capability satellite. Okay, so that initial development is not very high. Then we go for the near Earth satellite. Now, near Earth satellite, provided you have a requirement for remote sensing application, then we can go for that. Or
Okay.
in some cases, like the traffic control or any such aviation application, if you have, then we may have to go for the cluster of such satellites. Then we have to go
Okay,
for
just
the
to give you a brief, Dr.
Hmm.
Agarwal, it's like
Yeah, please.
when we started talking about this, and
Hmm.
Mr. Ram had been briefing us about you,
Yeah.
and we have, identified a few projects which could be interesting. So one
Yeah.
of them is going to be in the JPJ, they call it Jabatan Purbatan, the traffic, I mean to say the traffic, the roads ministry,
Okay.
and they want to secure their highways. So that's one of the things. Other one is we are working out with the GLC. It's the number one GLC, and they have acquired a couple of projects from the government. They are taking care of the defense of this country. That is the second one, and the third one is the in the Middle East. We are directly involved with the Interior Ministry of UAE. So I have a couple of jobs. He is dropped off. Can you? Oh, okay. He is
No, I'm
dropped off.
there.
So we may need
I'm
to.
there. I'm there.
No, no, no.
So
Oh,
he
Vasi, I think.
got.
Yeah. Vasi is there, but Vasi is speaking, sir. Vamsi, one more person from USA, California, right? That person is dropped. That's what he mentioned. Okay, Vasi, continue.
Okay, fine.
So I'm just typing him, ask him if he can wrap up and if he has questions. Never mind. So yeah, so these are the things that we have. It's quite impressive and really a good thought. And we don't have a single iota of doubt on what you just said and presented to us. And yeah, but it all depends on that we need to be on the same page.
Mm.
And when we uh, talk about the business or the penetration where we need to do it, it's all can be taken care of handsomely. We were very confident about it. But allow me to get the specifics from all these three, four locations, and then we may need to sit back again and discuss further how do we need to take it ahead.
Okay. We may only just why I want to just request to understand better. We may require,
Yeah.
uh, as I mentioned to you, the requirement, because how often we require to monitor, how often we have to have like a defense requirement, all those aspects. Once you can discuss and then like you can send RFQ, RFP to
Absolutely, Dr.
my side.
Agarwal. See, the thing
So
is
then I
like,
can work it out.
let me just brief you. You see, we are getting into something which is very, very sensitive. All
Yeah.
right. As an expat, no country would let you go in, but it all works out with the connections and the contacts and the network you have. And
Yeah.
by the grace of Almighty, it is all, you know, very good. It has been all very good. We may talk. I may talk about 18 years of my uh, here has been. I know people from 18 years who are ex and who are currently holding the chair.
Okay.
Now, we may mug up few things. We are the subject matter experts of the other fields. I know how does the government work in how, what are the requirements, what could be the budget, and what are the delivery timelines, blah blah, everything. But in here, the expertise that we are suggesting them or we are proposing them, you are the
Mm.
one who is
Mm.
the subject matter expert, right? Now, if
Okay.
I don't want to under promise or over promise anything. I would want my person or a client
Mm.
to hear from the horse's mouth, which is you, so that
Yeah.
you will calculate all four dimensions and you can be
Yes.
confident enough
Yes.
to tell them and explain them. And you will be the one who will
Mm.
front them. You will be the one to take the requirements and be on the specifics
Okay.
to deliver. All
Yes.
right. So I will
Yeah.
leave it, I will leave a card to you to ride it.
Okay.
But
Yeah.
before we reach out to, yeah, so I will explore, I will try to get things. Allow me, because I would have got it in this meeting, but I'm sorry, as I said, that my daughter has not been well, so it was an unavoidable call. She got admitted on Friday, so she may get discharged today.
Oh,
Allow me this week.
yes. I'm this week I'm in US. By 22nd or so, I will reach India. So 1 week you can take, and then probably after that we can have some meeting. Will that be okay, Dr. Venkataraman?
Yes, sir. Yes, sir. That's fine, sir. Yeah. I think
So-
Vasi voice
I
is
think-
low. I think
Venkat,
he's
we will tell you, we will talk with Vasi and we'll update you. So from there, you can update to Agarwal also.
What all
Okay.
Yeah.
Okay.
Yeah, we can't hear properly Vasi, but still he is speaking.
Yeah.
Okay, never mind. We will work out with the internal, sir, Dr. Agarwal.
Mm,
We
yeah.
will come back, sir.
Excellent.
Yeah.
Yes. Yeah, this will be fine. This is
And
absolutely fine.
only
So,
I
like
can
what I said,
assure you, we have expert of very highly qualified, experienced expert in each field.
Yes, sir.
So you
Yes,
don't
sir,
have to worry
I
about
don't have a
anything.
doubt about it. I
Yeah.
don't have a doubt
Yeah.
about it. I'm sure you have.
Yeah.
So I'll
Yes, sir.
really be happy to explore the options, and we can explore all together and
Yes.
see how we can mug up things. And here,
Okay.
because initially I was told about the trainings. Which,
That's
No, no. I will just tell you, when we discuss with Dr. Venkatram, so he says how to start with. Then I say there is a lot of university in the world. They look for
yes,
off-the-shelf items because
yes,
if they develop, so what we thought, we will make students to give some 1 week or 2 weeks training so that they can get into directly in the satellite project. Otherwise this kind of experience students they don't get directly, and in this
yeah.
process we can develop standard of the self item, so that like if you see the CubeSat shop, many items are developed by universities and they are available, you can buy off the shelf. So that was the starting point, but it was not.
I agree. That part can be that can be explored parallelly. But when we have a end user ready to opt
Yeah,
for
we don't
this
want
kind
to
of
waste.
technology, high end, why not?
Yeah.
Yes.
Yes, sir. That's what I'm thinking. It is we have a team to deliver that one also. First, we want to go with the end user applications like what
Yeah.
you are suggesting. What Agrawal suggesting is start with simple application, real application, and we will define some roadmap. And we will try to see which one is the low hanging fruit to start with. Then we can develop the proposal for you, response to your proposal. Once you are okay, then we can start delivering one by one.
And that will show capability also, because I know in the government agency one has to convince for anywhere. That is true for our country as well as for other country. We have to convince the government agency, yes, these companies are capable. So it's better we start some low end and keep on growing, and some time rate. So that
Yes,
is what we can tell. Okay.
Yeah, absolutely. Because the reason I am more interested in end user is because I have already explored. I am
I
currently
mentioned.
running 2 projects with the government, and the Minister of Technology is quite a good friend of mine. I have already briefed him. So I just wanted to understand from you first, what are we going to deliver? That was the reason I was holding up to this meeting.
Okay.
And now things are clear, and I can explore this opportunity.
Yeah. And
Thank you,
also,
sir.
Agarwal, sir, I
Yes.
want to add something. So why Vasi is also chasing to go for a big fruit? Because outside competition and the time we have, according to today condition, is very less. If we go with the small fruit and go to the big fruit, meanwhile the technology may change. We feel just
No.
like that. It's just a normal thing.
No.
We think
That
it's
I
not final.
understand. But
Yeah.
I have no problem in going for the larger project. Absolutely, there is no problem. But
Yes, sir.
I know how the government thing works anywhere.
Oh, yeah.
So because of that restriction, not that our restriction, we don't have
Yes, sir.
any restriction.
Yeah. It's only flavor added, sir. Nothing.
Yes.
Yes.
So,
Just to
so
convince
if it is
us.
a if it is a big project, I can form a dedicated team. They will be working round the clock. I say all the time to deliver the, because we may have to involve couple of more people depending upon the project size.
Yeah. Yeah.
Okay.
Because I was
See,
actually
as
expecting
to
some team
just to give
size.
you a just to give you a small highlight.
Hmm.
My last meeting with the minister, they are struggling with the palm plantation.
What
So
conclusion?
for the palm plantation, palm oil.
Palm plantation, yes.
So the farmers, they want to
Hmm.
have something which I have already taken the notes. I have few notes. I'll be forwarding it to you.
Okay.
And they are looking and I do understand pitching up for a government projects is quite difficult for an expert, but there is always a way to it.
Hmm.
And I have been doing that from 18 years.
Yeah, that's
Mr. Ram
good.
would be.
That's good.
So yes, that should be not an issue. We can. I will send you the documents. What current project we can work on?
For farm application,
For the
mostly they
farms,
require
yes,
remote
there
sensing.
are hundreds and thousands of acres which need to be tracked, which need to be monitored,
Hmm.
and we may need to. There is a plantation management solution which we may need to integrate with our satellite. So
Okay.
the specifics of that plantation management solution, I will forward it to you as well,
Okay.
and they will give us the access to their APIs and everything. So yes, it is there, and it's there in my mind. That is number one. Number two, there is one more country which, as I discussed earlier, they'll be looking forward to for the border tracking.
Yeah, that is very
Border
important.
tracking satellites. Yes. Yeah, we can explore. These are quite big, and I'm sure of we can explore these two further, because it's my bad that Mr. Wasim had to leave.
Yeah.
I will just as I said that we may need to sit back again to finalize the requirements what I have. In the meantime, let me just put them on the place, and let
Yes.
me align them with the correct framework. Then we can take it ahead.
Yeah. Meanwhile, if you can pass some little bit more details of that application, I will also study.
Yeah.
Because
Absolutely,
thing
absolutely.
before our
That
next meeting, I will get to know some more. You can pass on to AI Tech, and then I will study. Meanwhile, my colleague also will study what is
sure.
the constant required there. Okay.
Yeah. Wasi will do that. Yeah.
Absolutely, absolutely,
Okay.
absolutely. We can do that. No problem at all. All right, sir.
All right. Thank you very much.
Thank you guys for
Thank you
extending
very
the
much,
meeting.
gentlemen.
Okay.
Thanks a
Yeah.
lot
Thank you,
for
Thank
your
sir.
you.
time.
Thank you for
It
your
was
time, sir.
pleasant.
Thank you all.
It was really pleasant.
Yeah, thanks.
Have a good
Yeah.
day.
Today
Thank
is
you.
a great day. Nice day. Bye.
Thank you, everyone.
Thank
Bye bye.
you. Thank you.
Bye.
Thank you all. Bye.
Yeah, bye.
Thank you, sir.